Hello my dear students, in this lecture we will learn about the digital filters. So here you can see a chart of digital filter. So how the filtering operation took place. In filtering operation there will be some time and there will be some given signals and there will be an operation and we will get some values. So what are the filters we have to know? First of all, when we talk about filters, it means that really means that this filtering means that to make something purification or purify, just like water filter or else. But the concept is not like in the similar as in the digital signal processing, but quite equivalent or similar thinking you can impose here, because if you want to define the digital filters, there are some analog filters too, and there are some active filters and passive filters too that you have learned from the electronics 2 course when you were dealing with the filters, active filters with the operational amplifiers. So what are the filters? As you know, in communication systems, frequency is very important part, whether you transmit a signal or receive a signal. Whether I transmit a signal or receive a signal, frequency is very important part. So whenever you transmit a signal or receive a signal, so you need to have a desired signal to pass through a channel and also receive from the channel, and the desired signal will be transferred through the channel by its frequency. So the filters do the rest like that. They will take their desired frequency signals and just reject the other frequency signals. How they could do? What is the function? As you can see that if it is a high pass filter, that means there is a cutoff frequency and no low frequency signals will be allowed and all high frequency signals will be allowed. That is a high pass filter. That means high frequency will be passed through that filter. The low pass filter is the opposite of high pass filter. That means low frequency signals will be extracted and the high frequency filters will be rejected. Then the band pass filter, that means a certain band of upper frequency and lower frequency, there is a bandwidth and they will accept this signal through the bandwidth and they will reject the other band signals. The band stop signal is quite different and quite opposite from the band pass signal. Without the range they will accept all the signals, but with the range they will not accept the signals with the range that is specified in the band stop filter. So in digital filtering, it's all about bits and bytes and samples. So in the filtering operation, the time k has been shown here as samples 0, 1, 2, 3, 4, 5. There's no second or no timing units are giving here, and for that particular reason you get the different given signals are on different samples, and then we have to add these samples and get the value like that. The 14, 2.5, minus 9.3, minus 20.1, minus 28.8. That means there is some function that is go through to the digital filters that will give that kind of output. So digital filters have some equations, some filtering equations that will give this kind of values. Next, you get to know about filtering. Just look the two signals. On the top of the signal there is quite a scattered signal and it needs to be tuned. Okay, this looks like a semi kind of trigonometric sinusoidal cosinusoidal signal, but there are some uneven datas and uneven signals are going through to it. So after filtering, there is a smooth signal is going through to there, that is a smooth signal go through to there, but here there is, if it is the original signal, it does not be extracted like that because some scattered values are going up and down. So filters will make it a better value with a better result. Next, so that is the filtering section, and that is the digital filter. As you can see here, there are some system functions right on the xk minus 1, that means shifting filters are there. After shifting, all the values should have to be combined into a modulator. There is a plus sign circular object that you can see here on the bottom of the picture, and then you will get the output yk. Now in filtering there are three basic options required. First of all, delay, second is addition, and third is multiplication or scaling. So now go through to the digital filters. As you can see, there are general operation, more general operation, that is yk is equal to a naught k xk. So where are the scaling operations? As you can see here, the multiplication is the scaling operation. These equations, these coefficients are multiplied with each type of input signals. There is a single input signal go through to some of the transfer functions, and there are some weightages given as given here: a naught, a1, a2, a n minus 1, a n minus 2, and a n. And all of the things are the scaling parts. All of the data are combined with the addition and delay. What are the delay? As you can see here, xk, the delay value is k minus 1, k minus 2, and k minus n. That is the delay value. With every delay value, there are scaling properties, that's a naught, a1, a2, and an. And all the values are combined with the plus, and they are adding together and get the output right there. Okay. Now here you can see the impulse response, that is a naught, a1, a2, a3 up to an. And most general linear form is yk is equal to a naught xk, a1 xk minus 1, and an xk minus n, and minus b1 yk minus 1, b2 yk minus 2, and bm yk minus m. Linear form means there are some recursive forms, there are some input forms, and also some output forms with the different coefficient values. And delays, that is a recursive and infinite impulse response filters, they are known as IIR filters or infinite impulse response filters, recursive filters. So in digital filters, a simple first order is yk is equal to xk minus byk minus 1. If k is equal to 0, so y0 is equal to 1. If k is equal to 1, so y1 is equal to 0 minus b into 1 minus b. That means just put the value on there. If k is equal to 2, so you get y2 is equal to 0 minus b into minus b, p square, and so on. You get the digital filter like that. If k is equal to n, then yn is equal to minus b to the power n. As you can see in the digital filters, there are some transfer functions. Gz is equal to output z minus transform yz, and input z transform xz. For FIR filter, that means finite impulse response, yk is equal to a naught xk plus a1 xk minus 1, a2 xk minus 2. That means these are the delay parts, and both are multiplied with the scaling factors and additive in all the sections. And after z transform, you get all the sections are z transformed as xz, xz, all the xz's. And just for the shifting property, as you can see here, for xk minus 1, z to the power minus 1, just shifting property are there. And after that, the gz value will be the coefficient value of a naught plus a1 z to the power minus 1 and an z to the power minus n. That is the FIR filter. And what about the IIR filter? For IIR filter, that is infinitesimal value of gz, as you can see there. Okay,